So we're ultimately going to talk about conversions in the metric system, but I thought we'd start with an example in the imperial system so you can see something that's a little bit more familiar, and then ultimately see how much easier it is to do conversions in the metric system. So here, if we imagine we have a length of 1 mile, well, miles are pretty big, and I don't want to talk about, how wide my room is in, say, miles, right? That would be kind of burdensome. I'd have a really, really, really small number of miles within my room, right? So what do? We start breaking them up into equal blocks, and we do it 5,280 times. And we say that each one of those lengths, those equal lengths now, is 1 foot. And then we break up this foot into 12 equal blocks. Why 12? Who knows? And we call that an inch. And now we have a smaller unit that we can use for even smaller measurements that we're going to make. So if I want to start converting those, what mathematically I'm going to do, say I have a half a mile, I want to know how many feet that is. I'm going to take 0.5 miles, and I'm going to multiply that by my conversion factor. And our conversion factor is just a fact, okay? It's just the fact that there are 5,280 feet in 1 mile, okay? And I'm going to multiply that through. And so I get 0.5 times 5,280 divided by 1, and that's ultimately going to be 2,640. And what I'm going to do with the units is I'm going to cancel them. Okay, I'm going to wind up having these miles up here, right? And I'm going to cancel those with these miles down here. All right, and if you're wondering why that would be true, if you allow me to do a little scratch paper over here, what's going to happen when we do this math? We're going to have miles times feet divided by miles. So if I have miles times feet divided by miles, then mathematically I would cancel these miles in this case, right? So even if these were numbers, if this was 2 times 3 divided by 2, I could cancel the 2 and the 3. So I can cancel these miles just like I do I would numbers. And here I can just kind of skip ahead and say, okay, this guy's going to be in the numerator, and he's going to cancel with this guy down here in the denominator, my end thing. And I'm going to wind up with feet. So it's 2,640 feet. If I wanted to know how many inches that is, I'd have to take those 2,640 feet, and I'd have to multiply it by 12 inches for every 1 foot. Again, the feet are going to cancel. And I'm ultimately going to see that that's 31,680 inches. So getting to miles to inches really required, and that's only like really 2 steps here, but it really required a lot of knowledge, right? I needed to know first that there was 5,280 feet in a mile. I needed to know that there were 12 inches for every foot. And then I had to do some math that was, a little tricky here, right? It's not really nice even numbers. They seem kind of arbitrary in order to get to 31,680 inches. Now, let's look at this same kind of conversion if we're in the metric system. So the metric system does 2 very convenient things for us. It says that all our units are going to be factors of times 10, okay? And that the units are going to adopt prefixes instead of all new names, right? So first we had the mile, then we had the foot, we had the inch. Every time we're giving it a new name. Instead, with the metric system, we're going to keep a base name, and we're just going to keep changing the prefix on it. So let's see what that looks like. So if we start with our base unit of 1 meter, and we break this up into the next smallest unit in the SI system, we're going to have 1/10 of that meter, and we're going to call it a decimeter. And we're just going to put the prefix deci on meter. When we abbreviate it, it's just a small d here, and we're going to have one of those. The next smallest unit is going to be the centimeter. It's 1/10 of the decimeter, and we're just going to put this little c in front of it, and we're going to call it a centimeter. You can keep going. You got 1 millimeter, and all the way down to a really, really, really small number. They have some kind of prefix and some kind of unit that's each one just 1/10 of the other. So let's look at why this is nice for us. Let's look at this math here. So let's say that I have 0.25 meters, a quarter of a meter, right? And I want to know how many decimeters that is. All I have to do here is just say, okay, there are 10 decimeters in every meter. I multiply by 10 and I get 2.5 decimeters. All I had to do here is just move this over because it's a factor of 10. We just had to move the decimal place over 1. And similarly, if I wanted to know how many centimeters that is, I'd say, well, there's 2.5 decimeters. There's 10 centimeters for every 1 decimeter. I'll move this guy back over a little bit, and I get 25 centimeters. And I can do the exact same thing for millimeters, and I'd see that it's 250 millimeters. Now, the one thing I will say is that going every 10th of a unit sometimes doesn't always make the most sense, which is where people get a little confused, right? You really don't see decimeter used too much. You usually see people just talking about it's this many meters or it's that many centimeters. Maybe they'll get down into millimeters because sometimes that's convenient. But then, a smaller unit than a millimeter, they typically aren't going to use that till you're talking about very, very small things. So every once in a while, you'll see that they really skip one over and one of the units isn't used that much, which is fine. All you have to know is what conversion are you doing? If you're going from meter to centimeter, you need to know that that is 1/100th of a meter. So here is a table that I'm going to upload for you guys that has all of the prefixes and the values you would need to multiply by in order to convert between them. So if, say, you wanted to talk about a kilometer, right, then you would put the prefix K in front of meters, and you would say, okay, a kilometer is 1,000 meters, so 2,000 meters is 2 kilometers. And you can, you'll see that that's 1,000, and that you ultimately need to divide, in that case, going from meters to kilometers, by 10 to the 3. And you can see that there are many, many, many of them, and you'll see examples in different things. For instance, very large computers now have petabyte storage. Memory in computers is usually in gigabytes. And in the work we're going to be doing, little imperfections and stuff on what seemed like a smooth surface and stuff. If you looked at a microscope really carefully, you'd be down to something like the micrometer, nanometer scale. And then things can happen, like an atom would be done at like a picometer scale, right? They're really, really small, okay? And then chemical reactions can even happen at like a femtosecond scale. So 10 times, or 10 raised to the negative 15th of a second is how fast chemical reactions are happening sometimes.